Hello everyone. Welcome to the another lecture of Language of Chemistry class 8. Myself Suman Singh. So in the last class we have discussed about the valencies, right? So in this class we will discuss about the variable valencies and radicals. So what is variable valency? So from the name you can easily identify, right? Variable means what? Changeable, which changes with the time and which changes with the situations. Okay. So certain elements exhibits more than one valencies, right? Because in some conditions they will show different valencies, and some conditions they will show different valencies. Means what? There is a variable in valencies. Means this means their valencies are changing, right? So that is why there it is written here. It is written variable valencies. So certain elements will exhibit more than one valencies, and this means what? Variable valencies, right? So some of the example is also given here. So if it has been told here that if an element exhibit two different positive valencies, okay, if there is an element which exhibit two different positive valencies, then when we are writing its his name we will add, and when suppose try to understand like this. If there is one element, okay, and that element what it has done, what he has did, he has made a compound by combining with some other element. Okay, so at that time when he has combined with some other element, if he has exhibited the valencies which with the two different positive valencies, so at that time when the name we will write, when we will write the name of that element, we will write as ius in the suffix part. Prefix and suffix you know, right? Suffix means the this one, suppose this is a name, suppose this is a name, FERROUS. So this OUS is what? Suffix. It is written after the name, right? So I hope you have understood this. So what is written? If an element exhibit two different positive valencies, then ius is used in the lower valencies, and suffix ic is used when for a higher valency. Okay. Now nowadays, instead of using suffix ous and ic, we use the Roman name number with the bracket beside the name, beside one name of the element. For example of it is written here. Very good example is the example of ferrous. So ferrous exhibit two valencies, which is +2 and +3. Okay, +2 and +3. So if it is exhibiting the +2 oxidation state, it is writing as ferrous, or it can be written as iron 2. Okay, and when it is exhibiting 3 valency of 3, at that time it is written iron 1, 2 and 3, right? As you can see, for example, ferrous is written as iron 2 and ferric is written as iron 3. Now we know that non-metals like nitrogen, phosphorus and sulfur also show variable valencies. Okay, as you can see, it also show variable valencies. Sulfur also exhibit a valency of 2, 4 and 6, right? We have discussed about this. So I hope you have understood about the variable valency. Some more example is given here. As you can see, when we talk about the example of copper, its symbol is Cu. So copper exhibit two valencies. One is Cu plus, or we can say Cu2 plus. Okay, these are the two valencies. So it is written as a Cu1, here it is written as Cu2. So when it is exhibiting a +1 oxidation state, at that time it will be cuprous. When it is exhibiting a +2 oxidation state, it will be cupric. Again, iron, example of iron we have already seen. Now next example of silver, it is represented by Ag. So it exhibit two valencies, Ag plus and Ag2 plus. Okay, so when it is Ag plus, it is written Ag1, it is called argentinous, and when it is Ag2 plus, it is argentic, right? Now again, next is for lead, you can see Pb, it is, its symbol is Pb, and it has two valencies. One is Pb2 plus and Pb4 plus. Okay, so when it is Pb2 plus, it is written as plumbous, OUS, as you can see, and when it is exhibiting the 4 plus, it is been written as plumbic, plumbic. Now again with the example of teen, you can see Sn, it is exhibiting n 2 plus, Sn2 plus and Sn4 plus. So when it is exhibiting Sn2 plus, it is written as tonus, Stanous, and when it is exhibiting a plus 4, it is written as stanic. Now again in the case of mercury, its symbol is Hg and it is represented as Hg plus and Hg2 plus. When it is Hg plus, at that time mercurous, when Hg2 plus, mercuric, right? So I hope you have understood about the variable valencies, right? Now we will see next about the radicals. So what is radical? So radical, when you saw the name radical, it may be either positive. Radical is what? It is an atom, okay, of an element, or a group of atom of different element, okay, that behave as a single unit with either positive or negative charge on it, okay. Radical is what? It is an atom of an element, either it will be an atom of an element, okay, or it may be a group of atom group of atom group of atom, okay, that behave as a single unit. It will behave as a single unit, right, with either positive charge on them, or negative charge on them, okay. We will see one by one. So one is called basic radical. They are of two type. One is basic radical and one is acidic radical. So what is basic radical? So basic radicals are those radicals which they have, in which they have a positive charge, and it's also called what? Cations. Suppose Na, when we talk, and all metallic ions and ammonium ions are basic radicals. Suppose all metallic ions means Na plus, K plus, okay, Li plus, like this. All metallic ions are what? Yes, basic radicals. And suppose example of ammonium ion, NH3 plus, okay, NH3 plus. So these are all what? These are basic radicals, okay. Now next is acid radical. Acid radical is what? They are the radical. They are the negatively charged and also called anions. Okay, and most of the non-metallic ions are, and a group of non-metallic atoms with a negative charge are acid radical. Okay, in the, so you can take so many examples are there, like Cl negative, Fi negative, F negative, I negative, Br negative. These are what? These are the acid radicals. Okay, so one example is given here. We know that a molecule of common usually man-made a molecule of compound is usually made up of two part. For example, if we are taking the example of sodium chloride, it is made up of sodium ion, which is Na plus, okay, and chlorine ion, right, Cl minus, right. So as you can see, positive sodium ion, which is a positive charge, while the chlorine ion, which is a negatively charged, and it is represented by Na plus and Cl negative ion, as I have already told you, right. Na plus and Cl negative, Na plus and Cl negative respectively. Now the charge on these radicals is shown, so is the whatever the charge which is there present in this radical, as you can see Na plus and Cl minus, it shows is combining capacity, okay. Whatever the charge it is present in this elements, or it shows its combining capacity, which is called valencies, okay. What I have told you previously when we have started the valency, at that time I have already told you, right. Valency is what? It is the combining capacity of the element, right. So you can see this radical keep their identity in many reactions, right. So we will see one of some example. We will discuss about this table. When you see this table here, in this table it is written valencies and symbols of some common cations, which is positive radicals, right. So as you can see, monovalent means what? Only if it has given only one electron. If it is giving only one electron, then it is called monovalent. As you can see, Na plus is sodium, K plus is potassium, Cu copper, silver, mercury, hydrogen, and ammonia, right. Now if it is given, if he has given two electrons, suppose Mg, and if it is giving its two electron, then it will convert into Mg2 plus, right. So this Mg2 plus is called what? Bivalent, okay, because it has given its two electrons. So many examples is there: Mg2 plus, Ca2 plus, Ba2 plus, Zn2 plus, Ni2 plus, Cu2 plus, Fe2 plus, Pb2 plus, Sn2 plus, Ag2 plus, Hg2 plus, Mn2 plus, right. Now again, if if any element, suppose this is an aluminum, if it has given his 3 electrons and it is converted into Al3 plus, at that time it will be called trivalent. As you can see, trivalent. So your trivalent is ammonia, aluminum 3 plus, Fe3 plus, Cr3 plus. So these are all what trivalent elements, right? Now next is tetravalent. Tetravalent means 4. If Sn, it is given its 4 electrons, then it will change into Sn 4 plus. Okay, so this is called what, tetravalent. So as you can see, stannic, tin or platinum. So I hope you have understood this. Now next is when you talk about the negative radicals. So any time you can see here also you will get monovalent and bivalent and trivalent. So monovalent, if it is taken one electron, suppose Cl has taken one electron, then it is converted into Cl minus, right? So this Cl minus is called what, monovalent, right? As you can see, since it has taken one electron, monovalent, Br minus, I minus, OH minus, NO2 minus, HCO3 minus, HSO3 minus. So these are all what, these are monovalent. Why? Because they have taken one electron. Now in the same way, when we talk about the bivalent, suppose we have oxygen and if it has taken two electrons, then it will convert into O2 minus, right? So this is called what, divalent. Means these are the element which has taken two electrons, right? So as you can see, oxygen, sulfide, sulfate, sulfate, after that carbonate, chromate, dichromate, magnet, right? Now again, if some element has taken 3 electrons, suppose in the case of nitrogen, suppose it has taken 3 electrons, then it has converted into nitrogen 3 minus. This is called nitride. Okay, so this is called trivalent. So I hope you have understood what is monovalent, divalent and trivalent, right? So monovalent means in case when there is a positive, in case when there is a positive radical, at that time monovalent, divalent and trivalent or tetravalent means they have given 1, 2 or 3 or 4 electron. But in case of when there was a positive, negative radicals, and in case of negative radical, at that time monovalent means they have taken 1 electron, bivalent means they have taken 2 electron, trivalent means they have taken 3 electrons, right? So I hope you have understood this, right? So this was all about your variable valencies and free radicals. So in the next class we will start about the molecular formula and how to write the molecular formula. Okay, till that, thank you.